What we are going to really focus today is on sort of integrations and getting more value from integrations. Just to really quickly launch into introductions. For those of you that don't know me, my name is Christopher Young. I lead the risk team, risk and MBI team here at Pinnacle. And I've been working really closely with James on some of our sort of key risk projects. And so I'm just going to get James to introduce himself, and then we'll tell you a bit more.
Hello, I'm James Bruford, and I focus principally on Microsoft Azure and using the integration technologies within that cloud stack. But I also do some stuff with the Power Platform as well. So I've got the knowledge across the entire Microsoft piece.
And just before we move on, one thing that James hasn't told you is he started off life at Pinnacle working with me in the risk practice. So he has an intimate knowledge of the Pinnacle, the Intap new business intake piece, how that sort of connects and integrates with other things. So he's been using Intap Integrate and the Microsoft stack for integrating across a whole host of sort of applications. So hopefully this will be a sort of interesting and useful sort of conversation. So we've got a number of people who are joining this webinar series for the first time. For those of you that are and you've missed the previous ones, we'll show you how you can get to those a bit later on. But to give you a really quick summary of sort of Pinnacle, we're an implementation consultancy. We focus entirely on the legal sector, and we've got about 140 people. We work with Elite 3E, the Intap risk platform and Time. We have a small software development business which creates a product called Pitch Perfect, and also creates various integration tools and products that work with standard legal software. We're an Intap partner. We're a Elite partner. We know Aderant very well, and we run our business actually on these software products and have created many of these integrations ourselves. So we use 3E, we record time in Intap Time, and we use Power BI for all of our reporting and sort of dashboarding needs. So that's a really quick summary around Pinnacle. We have effectively three parts to our business. So we have a consulting practice, which is where James and I really sit. We've got a managed service business where we help look after the systems that we've helped implement, and then we have a software business, as I sort of said, and you can see our sort of partners in this slide. So that's all I'm really going to say about us. If you'd like to know more, please just ask the question, but that's for those of you that are new to this particular series. I keep on mentioning this word series, and this is the final one sort of before Christmas in our BI series. And it's really focused on effectively the integration piece and getting value from BI reporting using the Microsoft Azure stack. So that's what today's focus is. The previous sessions are all on our portal, and we'll show you how to get access to that if you want to see those later. So one of the things that we've worked through over the last over this series is these sort of three themes that we're sort of seeing from clients. And as I've said, this is focused particularly, this particular session is focused on integrations and the APIs. And we've had lots of conversations about actionable insights and putting Power Apps into dashboards and those sorts of things, and reminders and notifications. Today is focused at a slightly lower level. So, in terms of the sort of Microsoft stack, we've shown you this slide that's about to come up, before, which is, the Power Platform. So Charlotte, if we can move on to the next slide. So we've talked through the Power Platform and Power BI and Power Apps and Power Automate. We today are particularly focused on the data connectors, and that's what all of today's conversation is going to be about. Just before we launch into that conversation, we've got a really diverse crowd on the call today. So what we hope to do is to sort of, in a way, pitch this at the right level, not go too deeply technical and not be too superficial. So what I would say is, if you can help us to pitch it right by asking questions, that would be really helpful. So one of the things we're seeing in lots of our clients at the moment is that they're reviewing their sort of integration technologies and methods and thinking. And I think that's really being driven by sort of three key things. I think we can summarize it as: we've got some new technologies being brought to the market. So Intap, for those of you that know them, are moving clients from Integration Builder to what they call Intap Integration Services, or which is an OEM version of Boomi. And then also Microsoft has massively changed the capabilities and enhanced the Microsoft Azure stack. What we're going to do today is to talk about this Microsoft Azure stuff and some of the things that we can do differently sort of with it. The other reason that we think that people are needing to look at revamping their integrations is because they're moving to the cloud. In moving to the cloud, you will be rebuilding your integrations anyway. There's a thing that many folk don't really think about, which is that the destination, so the cloud services may not be available all of the time, and they might be being upgraded or doing those sorts of things. And so building resilience into your integration model is something that you can do as part of this, and we would argue should do, and firms to some extent should have been doing it a while ago, but the technology didn't really support it. And then what we're also seeing is there are various firms we're working with who are wanting, for corporate strategic reasons, to change the way their integrations work, either because they're moving BI up the agenda and they want new insights into their businesses, and the only way they can do that is by getting the data into their BI platform. The other thing that we're having some really interesting work and conversations around is how to make mergers quicker and easier, and in a way rebuilding your integration platform using some of the things that James is going to share with you in a bit makes that easier and arguably cheaper, but definitely quicker. So that was sort of really the introduction, and I'm now going to sort of hand over to James to work through some of the integration methods that we're sort of he's now using, and maybe it's a better way. Over to you, James.
Thank you. So traditionally, and I'm sure you've got lots of these in your firms, integrations have been built in a very point-to-point sort of architecture, which means that you've got a request that goes out from a particular system, it goes and does something, maybe some transformation, and then it'll load that data into another system. So this slide here is sort of exemplifying the fact that your extraction, your transformation, and your load is really encompassed within the same integration. And that was fine when most systems were on-prem. I mean, I guess in some ways it could have been made more efficient, but when you've got control over the entire estate, it's an okay integration architecture to use. As you can see from this one, this is identifying the practice management system as the source, and your core system entities that every law firm would have would then get pulled from that system, normally on a polling mechanism. You would look back 30 minutes or an hour or whatever it might be, and you'd have an integration that would then go and create those clients and matters in your new business intake system, or your time recording system, or your document management system. We've been building integrations like that, as Christopher alluded to, using Integration Builder for many, many years. And one of the problems that there's always been with that is how do you recover from errors? What tends to happen is, because you might have some Integration Builder integrations, you might have some stuff in SnapLogic, you may also have some custom code that is working with these objects. It's really, really hard to work out what's failed and what the impact of that failure is. What tends to happen is you only really realize you've got a problem when the problem starts to mount up and you're getting a lot of complaints from the user base, or you're getting some downstream issues with that data being incorrect between, or being different between the two systems. So how can we deal with that? What I'll do is, just before I move on, in order to just sort of give you an idea of what some of these terms are, because we're going to be referring to these later. This icon here in the center, this little workflow, that's indicating a logic app. But this could be any point-to-point technology, an integration builder rule, or whatever it might be. We have the next slide, please, Charlotte. So how might we re-architect this in Azure? Well, as Christopher said, one of the reasons that we might want to do this is because we're going to have more SaaS applications now. We don't know whether those systems are up at the time that we want to call them. And so the data transmission mechanism needs to be a really, really robust one that we can potentially recover from. So this is a sort of expanded version of the previous slide. And you can see that, again, we've got our source and target systems still in the lovely pink color. But we've got a couple of layers that separate those two, the source and the destination systems. So we can see here that we've got a messaging endpoint in our first column. And this could either be an HTTP endpoint, or dependent on your system. If you're talking to Elite 3E, for example, there may not be a mechanism for calling out from that system to an HTTP endpoint. So you could also implement a polling mechanism that can go and fetch that data on a regular basis. The middle column is indicating a service bus. And a service bus is a technology that acts as a message broker. And a message broker is something where you can send an event or a message, normally quite lightweight in its structure, and that will get put onto a queue. And then you'll have something that monitors that queue to then pick it up and process that data. With the Azure Service Bus, they've expanded it just beyond simple queues, which would be like a table that just had messages in. And they've expanded that out to allow you to create things called subscriptions. So what you can effectively do is you can have one client topic that will then send that same message to all of the systems that want to subscribe to it. So you've completely decoupled your source system from your target system. And you can put some other clever logic to filter things out as well. So as you can see from this slide here, we've got the practice management system that's feeding the NBI client subscription and the DMS one, but it's going to be filtered out of the PMS one because it's generated the message, so it doesn't need to consume it again. However, if you had a client message coming from the new business intake system, then obviously you'd filter out that one going back into the NBI system, and then you'd have that consumed into the PMS and the DMS in this case. So this is a slide that's talking about intap time. So one of the use cases that we're seeing at the moment is that people might have a time system that's on-prem and they're moving to a time system that's in the cloud. What we're suggesting here is that you can actually do some of this stuff in parallel. So rather than decommissioning your on-prem system and then writing new integrations that can go into the cloud system, into the cloud version, you can actually do this all within the same integration, so you can be populating the two systems at once. Was there anything on this one, Christopher, that you wanted to call out?
I think the particular sort of thing here is one of the things that we all are very excited about is jumping on clouds. One of the things that this sort of thinking allows you to do is to, if you like, move between systems in a relatively seamless and painless way, just by, you can run things in parallel. You can, for example, we've got one client where they're creating matters in two practice management systems because they've gone through a merger, and the downstream implications from the legacy practice management system, they haven't had time to decommission. So having these multiple subscriptions, potentially feeding into multiple systems, or a single subscription feeding into different applications, can be hugely powerful and can de-risk things like cloud migrations.
And it also gives you a lot of visibility as well. So you've got the ability to track these messages all the way through. So you can have lots of auditing in place that allows you to know that these messages have been consumed by both systems. Can we have the next one, please? So this is a very similar schematic that shows almost the reverse of the last system. So one of the scenarios that we've actually implemented in a few places is that when a time recording system is brought online that's in the cloud, you may not want to go with a big bang for that one. So you may have a rump of people that are still using the on-prem system while others are using the cloud, and you can actually drip more people into using the cloud instance. But you can have both of those sets of time cards being put onto a single time card topic, and then that can be consumed by the PMS processor. So you can have two time recording systems effectively feeding into the same practice management system. So it means that you don't have to do these big bang rollouts. You can actually, do it at the pace that you're comfortable with, rather than having to have cut over weekends and all of that sort of thing. So this is what it might look like once you've got all of the different pieces in place. So the square boxes that are dashed, these are the components that are going to be in Azure. And we'll just run through what some of these are. We'll look at the workflow and orchestration box first. There are various integration technologies in Azure, and there's massive overlap between all of them. And it's not necessarily a use one in one particular scenario and use another in a different one. They're sort of the same but different. So the ones here are logic apps. And a logic app is more of a traditional, if you're used to Snap Logic or BizTalk or Integration Builder, it gives you that user interface where you can drag and drop tasks on, do some activities on that data, and then you pass them on. They've got a very large number of triggers that allow you to actually instigate the tool. So you can either have an HTTP triggered Azure logic app, or you could have it triggered when you write something to a particular topic on a service bus. So every time it drops a message, it'll fire this integration off, and that makes it very, very scalable. If any of you are familiar with the Power Platform, Logic Apps and Power Automate, they're they're brothers. They're very, very similar. They look almost identical, except one's running in the cloud, in your Azure tenant rather, and one's running on Power Platform. The other integration technology that we do a lot of stuff with is using Azure Functions. And Azure Functions are serverless applications that, again, could be triggered through various means. The number of triggers aren't as voluminous as for logic apps, which is why you might choose one technology over another in a particular circumstance. But generally, when we're doing service bus integrations, we use Azure Functions. And there's a host of different languages that you can write those in. Generally, we use C# to write those Azure Functions, but they're a more pro-code variant. You've got lots of flexibility because you get to go and write all the code, so you can make it do whatever you want to. Logic Apps and Power Automate are much more lower code implementations. So you've got a much broader audience that can actually develop those integrations. The API Gateway box. This is something that doesn't have to be part of the solution, but a lot of firms want to have some sort of way of not only protecting their APIs that either they develop or they buy as part of their the SaaS solutions that they purchase, but also to prevent data leakage on the way out as well. So we've got a firm that we're working with where everything has to be protected on the way in and on the way out. So if you were using Chrome River or Intap, they've got their own APIs. We would actually put those API definitions into that API gateway, and that then protects what things can talk to it and also what things can talk out from that API gateway. So this is one of the themes that we're seeing a lot of in cloud. It's not just about improving the technology that we're using to integrate, it's how do we hold on to and protect our data, because obviously there's more scope for people to get their hands on. So as you can see in the third box, we've got the service bus and an event grid. These are two Azure messaging technologies, but they are different. We focus mainly on service bus because even though they do the same sort of job, event grid is very different. It's really, really scalable, and it's designed to push messages. And so if you've got something, if you've got a consumer of those messages that can't quite keep up, then you've got the potential for message loss. Whereas with a service bus, the message goes onto it and it stays there until something comes along to pick it up and then consumes it. So if you've got high value messages like the typical stuff that you run your business on, so users, clients, matters, time cards, probably a service bus is a better fit, because when you send a message, you've got it there and it'll stay there until something comes along and picks it up. So this diagram here is really just showing that you could potentially have logic apps or some sort of integration sending messages to your service bus, and then you could have message-based services that then pull information from that and then consume that into your downstream systems. With the next slide, please. So when it comes to reporting and warehousing, how can we leverage this architecture to feed that? Well, what we've said is that when you create your topic, and you would generally create a topic per object type or event type. So in one of the implementations we're working on at the moment, we have client topics and matter topics and time card topics. And then another one for reference data, actually, because reference data tends to happen. You tend to push that out on a slower schedule, because it seems it's obviously less volatile than client and matter data. But with a warehouse, you'd probably want to subscribe to everything. So whereas before, where we looked at the option of filtering out what messages we may not be interested in, with a warehouse, it can absolutely subscribe to everything. So it could get the time cards, It could get client and matter creations, or status updates as and when they occur. If you've got a new business intake system that's constantly updating and enriching those objects as they travel through their various workflows. You can also use it for the purposes of approvals. And this is something else that we're working on that may have been covered in an earlier session with regards to actionable insights. So when a client is created, it might be created with a status of pending, but it might need to go to a partner approval step before it gets fully opened. And so again, you can drive that notification logic by using these events and having a notification subscription that uses rules that you define to say this should go to a particular person for approval before it gets opened up and then propagates out to other systems. So you can really put some controlling logic in this service bus layer to manage the flow of data across your estate. Was there anything else you wanted to cover on the reporting side, Christopher?
So the one thing we've talked about is these sort of messages, and we haven't really sort of explored what's sort of in them. But one of the neat things about connecting your warehouse to your message bus is these messages will have, for example, time cards. It'll have all of the data that's needed to describe a time card in it. And if you just store the messages in the warehouse because they're subscribed to, you can effectively rebuild, refactor, do whatever you need to your warehouse without having to go back to your source systems, because you know how you've built up your data over time through these sort of messages, and you can effectively replay those messages in that rebuild or that refactoring or that extension or whatever it might be that you want to do. And the other thing that we haven't really spoken about, but again I think is hugely powerful, is you can listen for messages, for example, for changes at external data providers. So things like Companies House or registers. If companies are changing their name, you can consume that and feed that directly into your warehouse or into any other systems by putting those messages onto the message queue and doing whatever it is you need to do or think you need to do as a result.
And we're doing something similar. So you've obviously got the third-party data sources as well, but there's, even within your own Azure estate, using Microsoft Graph, there are events that you can listen to that you might want to piggyback off of and capture that data. So for example, if you were on a Teams call, if someone needs to go and record that time, they would normally have to put the phone down and then go and create the time card. But that Teams call is going to be registered in Microsoft Graph. So we can also create webhooks, which is almost like a reverse API. An event happens and then it'll tell us that event is completed, and it'll give you a message. And when we're talking about these messages, what we're talking about is, for the uninitiated, is some JSON or some XML. It'll be a sort of structured message that has sufficient information in there to either go and create the object in question, or it gives you enough information to then go and query that information from an API. So with the time card example, you could hang up your Teams call and then have that message get sent to a service bus, which would then be picked up by a consumer and then would go and create a time card for you in your time recording system. So it means that people don't actually have to go and interact with that data directly. They can, you can capture that information automatically in the background. And the service bus helps you do all of that sort of stuff as well.
That's what our Time for Teams tool does, which was created by James, and effectively has a message bus within it. So it gets the messages that you've hung up your call, and then it goes and tries to put the time card into your time recording system, and if it's there, great, and if it's not there, it'll wait until your time recording system comes back online, and we'll put it in as and when it's back up online.
Okay, so we've done we've done quite a few of these now, and we've come across quite a few of the problems. So this is really to sort of talk about some of the features that you would really need to think about when implementing a technology like this. And we've already spoken about integrations. We've obviously got the Power Platform and the Logic App stuff. Those are the user interface integrations, and it doesn't have to be an all, everything needs to be in one, either Power Platform or Logic Apps. You really can have a distribution of stuff. So if you've got citizen developers, I don't know whether many law firms allow their normal users to go and create these integrations, but if you are going to use the Power Platform, one of the things that we would really suggest is that you still have some software development practices sitting above that. So for those of you that use DevOps and source control, again, using that mechanism to release this stuff between your various dev, test, production tenants or subscriptions is a really, really good thing to do. It's amazing how easily you can break things without those sort of safeguards in place. Logic apps, they're really good. They're not as scalable as function apps are, but they've got a large number of triggers. So if you've got an entry point from, I don't know, like worksite, for example, a document gets created, there are connectors that allow you to trigger logic apps off of other applications that you might have. So there is a large number of those. So they're very good. The other thing that's quite nice about them is you get a visual representation of what is going on in the integration. You can replay them, that instance of a logic app. But yeah, then they're not as scalable as function apps are. Function apps require a little bit more development, a little bit more planning out. But I mean, that's what we would normally use if we were going to trigger things to and from service buses, creating microservices. The nice thing about them, though, is that they're all Microsoft technologies. And so one of the other benefits of doing this rather than having a distributed series of technologies that do integration is that you can feed all of the telemetry and errors into a central place. In Azure, we've got a tool called Application Insights, which gives you a full breakdown of errors, successes, anything that's gone through your system, and you can actually proactively notify when things don't go the way they're meant to. So you can actually start to tell the people that need to know that there's been a problem rather than waiting 2-3 weeks when you realize that you've messed up quite a lot of data that's going to take quite a lot of unpicking. So each of those technologies have their own place, and as I say, the nice thing about them is that they're all Microsoft, so they all integrate with this application. The other thing that's really, really important to consider before you get started is what's your data model going to look like. We've taken those 4 entities. We can see there users, clients, matters, and time cards. Another one might be parties. If you've got things that are not quite clients, but things that you want to relate to clients and matters. But the really key thing is to, before you start building, is to really think out what you want that content to be. And it doesn't have to be absolutely everything that each system holds on those objects. It doesn't have to be a superset. I mean, maybe what you want to do is just think about what is the common data that is going to be passed around those systems. And that would be your sort of common data model or your canonical data model. And the idea being is that you would then each system would transform into that canonical model, and that's what you would pass through your service bus layers, your queues, your topics, etc. And then you would have a consumer for each system that subscribed to those messages that would then take that and then convert it into its own system's object to create or update in that particular system. Another thing that we've been burned on is data standards. So, whether you've got a system that's dealing with ISO 2 or ISO 3 for countries, date formats can also cause a problem, and I'm sure everyone knows the pain that addresses can cause. So really thinking about the structure of addresses and what you want to send, was it if you've got addresses breast lines 1 to 4, all of those sorts of things really need to be considered as part of this translation piece. And in fact, I'm going to skip over operational data store and just go to the transform service. I'll come back to operational data store. It's amazing how many systems can have different codes for things like offices and departments within a firm. I don't know how it happens, but it happens everywhere. So one of the things that we sort of build as part of these service buses is a way of transforming reference data so that you can almost do lookups on the fly. And so this tends to be a custom API or microservice that would then take in that message from the queue, and anything that was a reference data point, it would then look up in a mapping table to then transform that into what is acceptable to be consumed by the target system. So coming up with that reference data mapping, if required, it's a good precursor to actually any build activities. Another thing that we found useful in the past is this operational data store. And what I mean by that is having a central database. So if we think of a SQL database that actually receives these messages, so it would actually be a subscriber to all of the subscriptions, all of the topics that we've got in the service bus, and it would store that data, and then it would, when we'd completed the write to that database, that would then emit another message that could then be picked up by downstream systems. So it would then go to those subscriptions, downstream systems. What that allows us to do is keep that message in very, very lightweight. One of the limitations, I suppose, of the service bus, dependent on the licensing model that you've taken out for that, is the size of the messages that you can store. I think it was a little while ago, it was 64 kilobytes. I think Microsoft have recently increased that a little bit. But some of these messages, if you've got, if you were sending a message from your new business intake system and you had a matter that was a class action or something, and you had lots and lots of parties related to that, you could very, very quickly breach those message sizes. So one of the strategies could be to write this data to an operational data store, and then when you send your message on to the system that wants to consume that, you just give it an ID, and then it'd be able to then go and query that database for the full message, and then consume that. There are other mechanisms and strategies that you could employ. That isn't a requirement, but it's something definitely to consider. It's been very, very useful for us for a particular client, where we can actually then go and call out to that database via an API, and you can actually get what the client or the matter look like on a particular date as well. So you can say, what did this message look like 2 weeks ago, and it will give you that, not just the current position. The other benefit of this architecture is the failure recovery, replaying messages. One of the things that we didn't talk about, we didn't want to get too into the weeds of the internals of how the service bus works, but when we've got the control, when we've got the message on a queue, we can be really, really clever about how many times we retry that. So if you've got a temporary outage to an API, you can make the message go invisible for a certain period of time, and it will be tried again when it becomes visible again. So you might make it go invisible for 5 minutes, wait for the API to come up. If it's up, when it gets retried, it will go through. If it fails again, it'll go invisible, and you can configure the number of times that happens. If you breach the number of times that you've set for retries, then you don't lose the message. It'll go to a poison queue or a dead letter queue, which is a copy of the queue that you put it on, but it's just for messages that fail to process. And then we can develop processes for actually replaying those messages. So again, it might be that an API was down for a long time, or Intapp were doing an upgrade of a tenant, and so you couldn't call the APIs for 5-6 hours. We can store those messages and then we can replay them at a later time. So it means that your ability to recover from those transitory errors is much greater than with the traditional point-to-point integrations. And then finally, security as well. As we spoke about, we've got the ability to put APIs into something like APIM or API management. Within Azure, you can define VNets and make sure that the things that you deploy within that VNet can only talk to certain other components. You can't have other people trying to call things, APIs that you've created to support this architecture from the outside world. And creating things like Key Vault. So there's another technology in Azure called Key Vault that allows you to store your API client IDs and secrets at rest. So you don't have to have any of those passwords like you might do in Integration Builder or some other technologies that are in plain text. They'll all be encrypted and they're just called out to as and when they're needed. So there's a bunch of things there that in the cloud you need to think about, but there are technologies and design patterns out there to help you fulfill them.
I think, James, I'm an outsider in terms of, I don't really do this development, but I see it from the outside. The key things are that you want to think about and make your decisions about this stuff pretty early on in the process, rather than trying to retrofit it, because that involves quite a lot of pain and sort of rework and rethinking.
Absolutely, yeah. We've felt that pain a good few times, that things aren't thought of in advance, and it makes things considerably harder.